Welcome back to the Deep Dive. Today, we're not just diving into data, we're really embarking on a journey into the very heart of industrial transformation. Imagine a factory that doesn't just produce, but actually thinks. Or a supply chain that doesn't just move goods, but, anticipates demand. Operations that aren't just managed, but actively optimize themselves. Our deep dive today is into techicom, a company that seems to be building the intelligence fabric for exactly that future. We've got a fantastic stack of sources here that paint a really vivid picture of how they're making this a reality. We're talking smart factories, super sophisticated supply chains, the works. Our mission today is to uncover not just what techicom does, but maybe the profound shift they represent for industrial businesses. We want to give you those aha moments, help you understand what it truly means to unlock industrial intelligence with these data-driven solutions, and maybe how that might redefine how you even see your own operations.
Absolutely. And, the industrial world is practically drowning in data right now. We're talking hundreds of terabytes daily, from thousands of sensors in just a single modern plant. It's staggering. But the real challenge, and our sources really bear this out, isn't collecting that data. Everyone's collecting data. It's extracting actionable intelligence from it. Right now, far too many critical decisions are still manual or they're reactive. Someone sees a problem after it happens, often delayed. This creates what techicom calls a significant efficiency gap.
An efficiency gap, okay.
Yeah, and they aim to bridge that gap, basically converting all that raw data into real-time insights and, crucially, smart operational plans. The goal is boosting efficiency, boosting visibility across the whole supply chain, manufacturing, even complex sectors like oil and gas.
Right. So they're really facing this data deluge head on. Let's unpack this. Let's see how they're actually doing it. How does techicom move beyond just, collecting data points to making sense of it all in a way that truly transforms how things run? At its core, techicom describes itself as an industrial AI company. Pretty straightforward. Building these data-driven solutions across, everything. Supply chain logistics, manufacturing floors, those vast oil and gas fields. They're taking raw inputs like GPS coordinates, video feeds, sensor data, and turning them into real-time insights and these intelligent operational plans. But what's the real secret sauce here? What's the actual, brain behind these transformations?
Right. Well, what's truly fascinating, I think, is that techicom identifies this really deep-rooted problem in industry. So much valuable operational insight is just locked away. It's trapped.
Trapped where?
In archaic PDFs, or incredibly complex P&IDs that's piping in instrumentation diagrams, for anyone unfamiliar, super detailed but hard to search, or lengthy standard operating procedures, SOPs. And then you've got all these disparate legacy systems that simply don't talk to each other.
Ah, the silo problem.
Classic. Exactly. It creates this profound disconnect. You've got an abundance of data over here, but a real struggle to extract actionable intelligence over there. And that inevitably leads to more downtime, missed optimization opportunities, and honestly, probably a lot of frustration for the people on the ground. So techicom's solution to this, as our sources reveal, is what they call the reasoning AI layer.
The reasoning AI layer. Okay.
Yeah, you can think of it as the intelligence fabric for industrial manufacturing, or maybe more evocatively, the industrial brain that powers all their specialized AI agents.
An industrial brain. I like that.
Me too. Essentially, it's artificial intelligence designed to think and reason like your best, most experienced engineers. But, at a scale and speed no human ever could.
That's a powerful analogy, an AI designed to think like your best engineer. But how does this industrial brain actually work? What are the components? What allows it to unify all this disparate data into something actionable?
Well, it's composed of several incredibly sophisticated yet distinct engines working together. In concert, really. First up, we have the inference engine. Now, this isn't just a passive data collector. It's actively processing information. It's looking for anomalies, it's predicting potential failures, and it's recommending specific actions before issues escalate.
Before they escalate, so proactive.
Exactly. Think of it as your plant's proactive problem solver. It can pick up on subtle shifts, maybe a slight vibration increase, an unusual temperature fluctuation, things a human might miss until it's too late, things that might signal an impending equipment issue. It gives you that crucial time to intervene before a really costly breakdown occurs. It's all about being ahead of the curve.
Okay, so that's the what might happen part. What else?
Then there's the context engine. This is absolutely critical. This is what gives all the data meaning. It maintains this dynamic, living memory of all your assets, their entire historical performance, their real-time operational states, everything. This provides the crucial who, what, where, and when for every single piece of data.
Ah, so context is everything.
It really is. Any insight isn't just a number floating in space. It's understood within its proper operational context. It learns from past behaviors, compares them to current conditions, and gives you a truly holistic view of what's happening.
So it's not just detecting a problem, but knowing exactly which pump on which line has the issue and maybe why it's significant based on its history and current load. That's a huge step towards real understanding.
Exactly. And critical for unlocking those trapped insights we mentioned earlier is the parsing engine.
The parsing engine. Okay, so this deals with the PDFs and diagrams.
Precisely. This component is specifically designed to extract meaningful data from those unstructured or semi-structured sources we talked about. Engineering diagrams like PNIDs and process flow diagrams, detailed operation manuals, those lengthy SOPs, even raw sensor feeds or handwritten operator notes sometimes. It transforms these opaque, static documents into dynamic, machine-understandable knowledge. It makes it usable by the AI.
Turning paper into power, essentially.
You could say that. And finally, we have the logic engine. This is where the human-machine interface becomes really intuitive. It translates natural language queries, basically, plain English questions, into industrial logic.
So I don't need to be a coder to ask it something complex.
Not at all. Instead of needing specialized coding or navigating complex dashboards, users can just ask questions naturally. Show me the energy consumption trends for line 3 this month. The system translates that into the operational commands or the data retrieval logic needed to pull up an accurate, immediate answer.
So if I'm getting this right, this reasoning AI layer isn't just collecting data. It's actively making sense of it, remembering its entire history, understanding complex diagrams, even interpreting my plain English questions.
Yeah.
That sounds like a massive leap from traditional SCADA systems or basic analytics.
It is. It's a fundamental shift.
Instead of engineers spending, like our sources said, 30–40% of their time just digging through information, this industrial brain lets them jump straight to intelligent action. But beyond those immediate efficiency gains for engineers, what's the bigger picture here? What's the fundamental shift this industrial brain signals for how companies might innovate or compete in the next, say, decade? Is this just about faster production, or is this something deeper, like entirely new business models or maybe a redefinition of what industrial expertise even means?
That's an excellent question, and it really gets to the strategic heart of it. It's much, much more than just faster production, though that's part of it, of course. This industrial brain signifies a real paradigm shift. Think about it. Historically, industrial innovation was often constrained by human capacity. How much information can one person or even a team process effectively, especially when it's scattered everywhere? With this layer, that bottleneck is essentially removed, or at least vastly widened.
So it frees up human potential.
Exactly. It redefines the role of the industrial engineer. They shift from being primarily a data sleuth, someone constantly hunting for information, to becoming a strategic decision maker, an architect of efficiency and innovation. They can now ask complex what-if questions. What if we adjusted this parameter? What if we rerouted this flow? And get data-backed answers in near real time. That enables continuous process improvement at a pace we haven't seen before.
And for the company itself?
For companies, this means a competitive edge derived not just from simple automation, but from intelligence-driven automation. That's the key difference. It allows for potentially new business models centered around predictive services. We can tell you when your machine needs maintenance before it breaks, or optimal resource utilization, hyper-customization, because your production system becomes dynamically adaptable in a way it never could be before.
So you can pivot faster, optimize for different things.
Precisely. You could optimize for sustainability one week, sheer speed the next, maybe ultra-high quality for a specific batch, all with unprecedented agility. It's about moving from that reactive problem-solving mode to proactive, even anticipatory operational excellence. It fundamentally changes how products are made, how they're delivered, how they're maintained throughout their life cycle.
That's a profound shift in mindset. Okay, so building on that powerful reasoning A layer, that industrial brain, techicom, then deploys what they call vertical AI agents. Each one designed to solve a specific high-value industrial problem. So these aren't just generic AI, they're highly specialized, right? Tell us more about how these agents work and what kind of specific problems they're tackling.
Yeah, exactly. If we connect this back to the bigger picture, these vertical agents are basically specialized applications built right on top of that core industrial brain. They leverage all that foundational reasoning power, but they focus it to deliver targeted, tangible solutions for specific pain points within different industrial functions.
So laser-focused AI.
You could say that. They focus on delivering measurable impact where it's needed most. Techicom highlights several of these agents in the materials we looked at, really showcasing their focused intelligence. One of the most impactful, I think, is DocParse AI. This agent sounds like a genuine game changer for information management in industrial settings. As we discussed, so much critical knowledge is trapped in documents, right?
Right, the P&IDs, the
All
manuals.
of it. DocParse AI literally transforms these things. Engineering drawings, complex P&IDs, PFDs, lengthy SOPs, even handwritten notes from operators sometimes. Comprehensive maintenance manuals that transforms them into machine-understandable knowledge. And it's not just scanning them to make a digital copy. It's creating a comprehensive, searchable, digital knowledge graph out of them.
Wow. So essentially, techicom is turning decades of industrial paper shuffling, the kind that probably gives engineers nightmares,
Oh, absolutely.
into a fully searchable, intelligent database. I remember trying to find one specific detail in an old manual once. It felt like looking for a needle in a haystack made of other equally important haystacks.
Exactly. And this tool, DocParse AI, it basically eradicates that nightmare, or aims to. It means replacing potentially weeks of manual interpretation, tedious data extraction, with mere seconds of AI-powered analysis.
That's
Imagine the enormous time savings. For engineers who, as our sources highlight, might spend a staggering 30 to 40% of their working day just sifting through information, desperately trying to find that critical detail in an old diagram or a long-forgotten manual update. DocParse AI allows them to instantly access that information, and then they can focus on acting on the insights rather than spending all their time hunting for them. It's about making institutional knowledge instantly accessible, bridging those organizational memory gaps that plague so many companies.
Okay, DocParse AI tackles the document challenge. What else?
Then there's the conversational AI copilot. This is where techicom really pushes to democratize access to plant intelligence, making it accessible to everyone, from executive management right down to frontline operators.
How does that work, like a chatbot for the factory?
Kind of, yeah, but much more powerful. It allows users to ask natural language queries about their plant, using their own words, and get instant answers. Tables, charts, actionable insights. Think of it like a really smart assistant specifically for your factory floor or your entire operational overview. You can just ask, show me energy usage versus throughput last month, and bam, you get an immediate visualization.
No complex queries needed.
Nope. Or highlight the machines with the highest downtime this quarter, and it delivers a clear performance table. It can even summarize yesterday's shift report, delivering concise text summaries. Think of the hours saved just compiling reports. This effectively puts complex data analysis capabilities into the hands of anyone who needs it without requiring them to be a data scientist or learn a specialized tool.
Okay, here's where it gets really interesting for managers and operators on the floor. Instead of digging through physical binders or trying to navigate those often clunky dashboard interfaces, or maybe waiting hours for an expert to compile data, they can get real-time, context-aware answers just by asking.
Exactly.
It truly democratizes access to plant intelligence, like you said. It lets them understand not just what happened, but potentially why it happened and what steps they might need to take, all through this intuitive conversational interface. That could really change daily workflows.
And critically, there's another agent, Compliance AI. This one transforms audit management, which, let's be honest, is often a manual reactive headache for many companies.
Oh, definitely. Audit season dread.
Right. Compliance AI aims to turn it into a streamlined, proactive process. It automatically scans and interprets all sorts of audit reports, things like process quality control systems or PQCS reports, which ensure product consistency, general safety audits, ISO requirements for quality management, all that stuff. It identifies and categorizes any nonconformities it finds by severity level. It tracks their closure progress, maybe assigns responsibility, and it even performs trend analysis on repeat failures to help identify underlying systemic issues.
So it spots patterns you might miss.
Exactly. And crucially, it sends proactive alerts before deadlines loom, ensuring audit readiness, helping manufacturers stay ahead of regulatory requirements. It provides this unified dashboard with real-time visibility into audit status. No more last-minute scrambles or potential penalties because something fell through the cracks.
That's a huge benefit, especially in highly regulated industries like pharma or food and beverage. It sounds like a really sophisticated foundation for not just understanding, but proactively managing pretty much all aspects of an industrial operation. Okay, let's move on to another core offering, cameras. They're everywhere in industrial settings, right? And beyond. But traditional systems, well, they often rely on someone watching screens manually, or maybe just basic event-triggered alerts. How is Techicom's ViewOS changing that? How are they extending this democratization of intelligence to the visual world, which is so often manually monitored or underutilized?
Yeah, that's a great point. And it raises an important question. Why do we actually deploy cameras in these environments in the first place? Fundamentally, it boils down to finding out, what already happened
Right.
after an incident or what's happening right now for situational awareness.
Yeah.
And most crucially, what will happen, the predictive aspect.
Seeing the future through the lens.
Sort of.
Yeah.
ViewOS, which is Techicom's comprehensive visual intelligence operating system, aims to empower virtually all cameras, whether they're standard conventional IP cameras, older analog setups you might still have, or the very latest smart cameras packed with features. It layers AI-driven analytics on top of those feeds to cover all three stages: past, present, and future. It really tries to bring intelligence to every single frame. Most existing video analytics solutions tend to focus only on what already happened, forensic analysis, basically. ViewOS aims for true predictive power, turning what's often passive surveillance into proactive, actionable insight.
Okay, so it's trying to be more than just a VMS, a video management system.
Much more. And our sources highlight that ViewOS tackles several significant challenges that plague the current video analytics market. Many existing solutions, for example, offer only a limited set of ready-made use cases. They're often tied to specific hardware from the original equipment manufacturer, the OEM.
Vendor lock-in.
Exactly, which severely restricts customization and scalability. Then there are major integration issues because plants often have a diverse mix of camera technologies installed over the years. Getting them all to work together smoothly can be a real headache.
Yeah, I can imagine. Compatibility nightmares.
Right. And of course, there's the cost factor. High capital expenditure from rigid pricing models, steep upfront costs. It often makes advanced video analytics difficult for businesses, especially smaller ones, to adopt.
So what you're saying is ViewOS tries to overcome these hurdles by integrating, ideally, seamlessly with any camera system, regardless of its age or manufacturer. And it comes loaded with this big library of built-in AI use cases, ranging from basic security to really advanced industrial inspection.
That's the idea.
And it's designed for adaptability, letting users browse, deploy, customize these use cases, and, crucially, only pay for what they need through maybe flexible pricing or subscription plans. Is that about right? It sounds like a universal translator for your camera feeds, turning them into actionable data, not just for one specific type of camera or one single purpose.
Precisely. It's about making every frame intelligent, extracting value from the visual data you're already collecting, regardless of the camera's age or type. ViewOS offers this vast library of pre-built AI use cases. Users can browse them, deploy the ones they need, customize them to their specific environment. And as you said, the goal is flexible payment, pay only for what you need. This modular, flexible approach allows for easy switching or upgrading of use cases as needs evolve. Let's look at some of the most impactful examples across different sectors based on the sources.
Okay, let's do it.
All right, so for industries and innovation, ViewOS provides some truly transformative solutions. A prime example is defect detection.
Quality control with vision.
Exactly. This is a powerful application where the Vision AI meticulously inspects products. It can detect microscopic surface defects, think tiny cracks, glazed pinholes, and ceramic tiles, subtle color variations that the human eye might miss consistently. It ensures automated grading and sorting of products based on quality criteria. This significantly reduces customer complaints, minimizes costly rework or scrap, and helps prevent those expensive export rejections by ensuring consistent quality standards right off the production line.
Catching problems instantly.
Right. Another crucial one is worker safety and activity monitoring. This uses computer vision and real-time video analytics to dramatically enhance workplace safety. It also helps ensure compliance with safety protocols and can even optimize workforce efficiency by understanding movement patterns. For instance, in a manufacturing facility, it could immediately identify if someone's missing required protective gear, like a hard hat or safety glasses, or flag unsafe worker behavior, like entering a restricted zone without authorization, or detect unusual crowding in potentially hazardous areas.
And it sends alerts.
It provides real-time alerts for quick intervention. These examples really show how a simple camera, enhanced with ViewOS, becomes a proactive safety and quality inspector, 24/7. Other powerful use cases in this area include things like gas leak detection, using thermal cameras perhaps, or assembly verification to make sure products are put together correctly, all aimed at automating oversight and boosting efficiency and safety.
Okay, that covers industry. What about other areas?
Moving to people and infrastructure, ViewOS drives improvements in areas like retail analytics and smart surveillance.
Okay, so outside the factory now.
Yeah, think optimizing store operations, getting deeper customer insights. It can track customer movement, anonymize, of course, measure dwell times in specific areas to inform store layout or product placement decisions, even analyze buying patterns. It can also detect suspicious activities for loss prevention, monitor inventory levels on shelves visually, and watch checkout queue lengths to optimize staffing and improve the customer experience.
Making the retail space smarter.
Right. Another key use case here is parking management providing real-time occupancy information, guiding drivers to empty spots, or occupancy monitoring in buildings for crowd control and ensuring safe utilization, especially important these days.
Makes sense. And for security applications.
And for governance and security, VOS offers robust solutions. For example, ammunition and weapon detection.
Wow, okay. That's serious.
It is. This is a crucial AI-based system that automatically detects firearms, knives, or other suspicious objects in high-risk environments like banks, airports, or public buildings. There's a compelling case study mentioned where an OEM developed this solution specifically for a public sector undertaking, PSU Bank in India. The system integrated with their existing CCTV networks, triggering instant alerts to security personnel upon detecting firearms or ammunition. This significantly enhances security monitoring and speeds up response capabilities.
Proactive threat detection.
Exactly. This proactive threat recognition allows security agencies to potentially mitigate risks much more effectively than just relying on human monitoring alone. Other important use cases in this domain include license plate recognition, LPR, for access control, vehicle tracking, or law enforcement, and perimeter monitoring to detect unauthorized entries into secure facilities.
That flexibility, combined with the ability to turn potentially any camera into a smart AI-driven solution without necessarily needing costly hardware upgrades, that really does sound like a game changer for accessibility. It lowers the barrier. But thinking practically, for businesses with deeply entrenched, maybe proprietary, older camera systems, what are the common hurdles they might face in achieving that seamless integration you mentioned? Is it always straightforward, or are there specific technical challenges to anticipate that our listeners should be aware of?
That's a very fair and important point to raise. While VOS is designed for seamless integration, challenges certainly can exist, especially with truly archaic or highly proprietary closed systems. You're right, it's not always magic. The main hurdles typically involve things like older network infrastructure. Maybe the network just wasn't built to support multiple high-bandwidth video streams needed for real-time AI processing across many cameras.
Bottlenecks.
Exactly. Or you might encounter legacy camera firmware that uses non-standard protocols or requires specific, maybe undocumented, APIs application programming interfaces to actually extract the video feeds reliably.
So you need a way to talk to the old tech.
Precisely. However, techicom's approach seemed designed to mitigate this significantly through its modular architecture and often the use of edge computing. They frequently deploy edge devices. These are small, powerful computers located near the cameras. These devices can process the video at the source, running the AI models locally.
So you don't flood the network.
Right. They only need to send relevant metadata like alerts, object counts, or event triggers back to the central cloud or on-premise servers. This drastically reduces network strain. And these edge devices can often handle diverse camera inputs, acting as a kind of translator or gateway for even the most stubborn legacy systems. So while it's not always a simple plug-and-play, especially with very old gear, their design deliberately tries to minimize those integration complexities. The aim is definitely to work with existing infrastructure wherever possible, rather than forcing a complete, expensive rip and replace.
That makes a lot of sense, especially for companies that have made significant investments in their existing systems over the years. Okay, so VOS brings this incredible visual intelligence layer, but techicom's offerings, as you said, extend much further into other critical industrial areas. Let's shift gears now to their broader product suites and solutions that go beyond just what a camera can see. What else is in their toolkit?
Indeed, techicom offers comprehensive solutions that move well beyond just vision. They delve deep into machine health, energy management, and crucial location intelligence. They group these capabilities into specialized product suites, notably Watchtower and Energy 4.0, and all of these leverage that foundational reasoning AI layer, that industrial brain we discussed at the start. So it's all interconnected.
Okay, let's start with Watchtower. What's that focused on?
Let's first look at Watchtower. This is their suite specifically for condition and asset intelligence. It's primarily focusing on machines and maintenance, keeping the physical plant running smoothly. Within Watchtower, you get robust equipment health monitoring. This provides real-time tracking of your critical assets. Think kilns in a ceramics plant, dryers, polishing machines, vital pumps, compressors, the heart of the operation. It's not just logging data points passively, it's actively detecting subtle anomalies, unusual vibrations patterns, temperature spikes that are outside the norm, maybe pressure fluctuations, things that indicate stress or a developing problem before these issues escalate into full-blown failures.
Catching problems early.
Exactly. The system provides a clear dashboard showing things like machine uptime percentages, calculated health scores for each asset. It gives operators an instant visual overview of their plant's pulse. This proactive monitoring allows for early intervention, preventing minor issues from snowballing into major, costly crises.
So it's really about shifting from that reactive repair mode, fix it when it breaks, to a more predictive maintenance approach, giving you a crucial head start.
Exactly. And the AI really shines with the next component, predictive maintenance and remaining useful life, RUL, prediction. This is where it gets really sophisticated.
Remaining useful life, so predicting the future.
Pretty much, yeah. This is where advanced AI models, trained on historical data and real-time sensor feeds, actually forecast when specific components are likely to fail. Things like kiln rollers, the refractory lining inside a furnace, critical motors, bearings. This capability generates proactive maintenance schedules. It tells you should probably inspect or replace this bearing within the next 2 weeks before any breakdown actually occurs.
That's huge.
It is. This significantly cuts unplanned downtime, which is often the most expensive kind of downtime. And it vastly reduces those emergency repair costs, the overtime, the rush shipping of parts. There's a compelling case study mentioned in the sources highlighting a large-scale manufacturing unit. By deploying techicom's RUL prediction model, they were apparently able to extend the life of their rotary kiln bearings by a remarkable 30%.
30%. Just by optimizing maintenance.
Just by performing optimized, data-driven maintenance interventions at the right time, based on the AI's predictions, rather than just relying on fixed schedules or waiting for failure. This really shifts maintenance from being seen as just an expensive reactive cost center to becoming a strategic, efficiency-driving function.
Turning maintenance into a profit driver almost.
In a way, yes, by maximizing uptime and asset lifespan. Watchtower also features an e-logging system. This might sound simple, but it's a crucial digital replacement for those traditional, often messy, manual logbooks kept on the factory floor.
Getting rid of the clipboards.
Exactly. Operators can easily enter shift notes, record key machine parameters, log downtime causes and durations directly into a digital system. This creates a central, searchable, and always available electronic record. This is invaluable for audits, obviously, but also for efficient troubleshooting later on and ensuring clear accountability and knowledge transfer across different shifts. It moves away from those fragmented, sometimes illegible, paper-based records.
Okay, so Watchtower handles asset health and maintenance. What about Energy 4.0? That sounds sustainability focused.
Precisely. Next, we have Energy 4.0, which is techicom's suite dedicated to energy and sustainability intelligence. This is all about optimizing resource consumption, reducing waste, and promoting sustainability across the enterprise, which is, as you say, a critical focus for so many businesses today, driven by costs and regulations. It offers detailed energy monitoring. This means meticulously tracking gas consumption, fuel usage, electricity draw, right down to the level of individual equipment or specific process lines. This granular data allows for a precise understanding of energy usage patterns, often revealing hidden inefficiencies that weren't obvious before.
Finding the energy hogs.
Basically, yes. It also enables intelligent cost benchmarking. It calculates specific energy costs per unit of production. For example, the energy cost per square meter of tile produced in a ceramics factory, or per batch in a chemical manufacturing process. This helps identify which lines or processes are inefficient, allows for comparison across different production lines or even different facilities, and really pinpoints areas for significant cost reduction.
Making energy usage tangible.
Exactly. And powered by AI, it provides optimization guidance. The system doesn't just report the numbers, it suggests concrete savings. Maybe through adjustments like fine-tuning kiln temperatures slightly, optimizing drying cycle times, or suggesting better load balancing across machines to avoid peak demand charges. It also offers comprehensive carbon and emissions tracking, monitoring CO2, NOx, particulate matter emissions, helping businesses meet compliance reporting requirements, and track progress towards their sustainability initiatives and goals. It aids in building that greener footprint.
That's a truly powerful combination, moving from just tracking consumption to actively predicting issues, optimizing performance for both operational efficiency and environmental responsibility. That covers a lot of ground. But what about location intelligence? You mentioned GPS earlier, and the initial outline highlighted geofencing. How does that fit into this comprehensive platform, especially in a dynamic world where physical assets and people are constantly on the move within a site or across a supply chain?
That's a good question because location data, when it's processed intelligently, becomes a real cornerstone for efficiency, safety, and accountability in a very tangible way. It's not just dots on a map. Techicom leverages real-time location data for critical operational control and safety through their geofencing and geo-tracking solutions. These seem designed to empower businesses to maintain smarter boundaries and safer operations by providing significantly enhanced visibility and automation based on where things are.
Smarter boundaries. How does that work?
Well, they enable the ability to define zones, map movements, and enforce boundaries. This means users can create intelligent geofences. These are virtual perimeters overlaid on a map of their site or area of operation. They can assign specific rules or geohashes to high-value zones, restricted areas, or staging locations. The system then tracks asset entry, exit, and movement across these mapped areas in real time, using GPS, RFID, Bluetooth beacons, or other location tech. It provides immediate awareness of where everything and everyone is or isn't supposed to be. This is incredibly useful for security, compliance, and managing workflow efficiently.
Okay, so you define the space virtually. What then?
Furthermore, it offers live movement, smart paths, and predictive insights. You can visualize literally every step an asset or a worker takes on site on a live map. You can analyze their routes for efficiency. Are they taking the optimal path? You can detect anomalies in their movement patterns. Maybe a forklift idling too long in a specific area, indicating a potential bottleneck or delay. Or even forecast behavior, like predicting arrival times based on current movement before potential issues like delays arise. This transforms static location data into dynamic, actionable intelligence, giving you a full picture of movement and flow.
So you can see inefficiencies in motion.
Right. And ultimately, it's about enabling smarter routes and safer zones. The system can analyze historical movement data to optimize asset paths, suggesting routes for maximum efficiency and maybe fuel savings, helping to cut operational costs significantly. Concurrently, it provides instant alerts when assets or personnel enter restricted or sensitive areas without authorization. Think hazardous material zones or secure inventory areas. This significantly enhances safety and ensures compliance with operational protocols. It's like building a dynamic digital fence that's constantly aware and reporting exceptions.
That's a truly impressive breadth of applications just based on location. What are some real-world scenarios where this kind of location intelligence is making a tangible difference for businesses? Can you give us some examples?
Absolutely. The applications for this location intelligence are incredibly diverse, popping up across many different industries. In construction and infrastructure, for instance, it's used heavily for restricted zone monitoring. Ensuring no unauthorized personnel or equipment enters hazardous areas or active construction zones is vital for site safety.
Keeping people out of harm's way.
Exactly. It also facilitates worker time and zone tracking. This helps manage labor efficiency, how long are crews spending in specific work areas. And it aids safety compliance by ensuring workers are where they should be for the right duration for their assigned tasks. Equipment movement tracking provides visibility into the usage and location of expensive heavy machinery, helping optimize its deployment and prevent theft or misuse. And automated attendance and safety logs, based on workers entering and leaving defined site zones, can replace manual sign-in sheets, ensuring accurate records for payroll and safety briefings. All this helps create a safer, more controlled job site by reducing the need for manual oversight and enhancing compliance through real-time alerts and automated reports.
Makes sense for complex, dangerous sites like construction. What about logistics?
For supply chain and logistics, the benefits are huge. It enables live vehicle tracking and ETA prediction, providing customers and dispatchers with accurate delivery timelines, which improves customer satisfaction and operational planning. It allows for setting up geofence loading/unloading zones. Trucks get automatically logged in and out as they enter or leave the designated dock area, streamlining operations and reducing manual check-ins. It enables cold chain monitoring by integrating temperature sensors with location tracking for temperature-sensitive goods, ensuring their integrity throughout transit. And it performs route optimization and rerouting, adapting delivery routes in real time based on traffic conditions, weather, or unexpected delays reported by drivers or external feeds. With live location data and intelligent automation, supply chains become more predictable, more responsive, and much more efficient, minimizing delays, reducing spoilage, and cutting down on uncertainty.
Okay, construction, logistics. What about inside a factory?
Inside manufacturing environments, too. It facilitates tracking of work in progress, WAP assets. You can see exactly where specific batches or components are physically located on the production line, helping visualize flow and identify bottlenecks. It enables personnel tracking in high-risk zones purely for safety alerts, ensuring workers don't linger in dangerous areas near heavy machinery, for example. It can automate material movement logs as materials pass through different stages, and it assists with maintenance crew location-based task assignment, ensuring the closest or most appropriate technician with the right skills is dispatched to a machine needing attention. AI-driven location tracking inside the plant streamlines operations, improves worker safety by enforcing zone restrictions, and provides complete traceability across the production line without adding manual bottlenecks for tracking.
And fleet management seems like a natural fit.
Absolutely. Finally, in fleet management, it empowers driver behavior analytics, monitoring things like speeding, harsh braking, or excessive idling to promote safer driving habits and identify areas for driver training, potentially lowering insurance costs. It ensures geofenced route enforcement, sending alerts if a vehicle deviates significantly from its planned route, which can help prevent unauthorized use or side trips. Fleet health diagnostics and predictive maintenance, often linked with onboard diagnostics (OBD) data, use location context alongside vehicle data to manage upkeep and flag potential issues. And it provides crucial alerts for potential fuel theft. For example, if a vehicle stops for an unusual amount of time near a known fuel theft spot or unauthorized stops. Smart fleet tracking clearly empowers better driving habits, reduces operational risks like accidents or theft, and cuts costs through real-time insights into how vehicles are being used and their overall health. There's a compelling case study mentioned in the sources involving a government-owned milk processing plant. They were having issues with potential adulteration or theft from their tanker fleet.
Yeah, that's a classic supply chain risk.
Right. By implementing techicom's geo-tracking and geofencing system, they enabled real-time monitoring of their entire tanker fleet. They automated route adherence checks against the planned delivery routes, and they received instant alerts for any unauthorized deviations or unscheduled lengthy stops. This apparently significantly reduced their losses, ensured timely deliveries of fresh milk, and even helped prevent product adulteration by maintaining much stricter route compliance and providing an auditable trail of movement.
That's a fascinating cross-section. It really shows how location data, when it's intelligently processed and integrated, isn't just about dots on a map anymore. It's about building this tangible foundation for efficiency, safety, compliance, and accountability across so many different industrial contexts. Okay, this is incredibly comprehensive. It sounds like techicom offers solutions for almost every facet of an industrial operation. We've talked about the industrial brain, the specialized agents, the visual intelligence with VOS, asset health with Watchtower, energy optimization with Energy 4.0, and now location intelligence. How do they unify all this intelligence for true enterprise-level improvements? How do they make sure all these different parts, these different signals, actually work together as a cohesive whole rather than just creating more data silos?
That's the critical question, isn't it? Because having lots of point solutions doesn't necessarily lead to enterprise transformation. This is where the one platform, unified solution concept really comes into play. Techicom's ultimate goal, it seems, is to eliminate those operational blind spots and drive truly data-driven decisions across the entire enterprise, not just within one department or function. They integrate all these specialized capabilities we've discussed: vision, condition monitoring, energy, location, document parsing into a cohesive platform. They're designed to communicate and, importantly, learn from each other.
So the data flows between modules.
That's the intent. First, there's real-time unified data integration and process optimization. As we've touched on, fragmented data across all those different systems, IoT devices spinning out sensor readings, the ERP system managing orders and inventory, the MES controlling the shop floor, maybe separate quality control systems. That fragmentation is a huge pain point for industrial businesses. Techicom's platform seems to excel at consolidating this diverse data into a single, unified real-time dashboard or data layer. This eliminates those operational blind spots where one system doesn't know what another is doing. And it enables those predictive insights we talked about, allowing for automated workflows and more seamless, informed decision-making across functions. One compelling case study mentioned involved a leading public sector enterprise. They partnered with Techicom to unify operational data across their multiple data centers. This involved pulling together information from ticketing systems for IT issues, server performance metrics, network monitoring tools, even procurement workflows, handling, they said, over 100,000 daily data points.
That's a lot of data points.
It is. This integration apparently eliminated the data silos between different teams, led to a reported 20% improvement in resource allocation efficiency within the data centers, and significantly reduced the time it took to resolve IT tickets, ultimately enhancing their overall operational agility.
Okay, so step one is bringing the data together. What's next?
Next, they offer a powerful capability. Digital twin for process simulation and asset management. Traditional asset monitoring, as we discussed with Watchtower, often focuses on current health, but might struggle to predict complex interactions or optimize entire processes.
What exactly is a digital twin in this context?
It involves creating detailed virtual replicas of physical assets, a specific machine, a production line, or even an entire industrial site. It's a dynamic model. By continuously feeding this virtual model with real-time IoT sensor data from the physical asset, plus historical maintenance records and operational parameters, it allows you to simulate operational scenarios. You can optimize machine performance in the virtual world first. You can predict failures with greater accuracy by seeing how different stresses affect the virtual model. And you can significantly improve maintenance scheduling based on these simulations. Operators can simulate different strategies like, what happens if we adjust the machine load by 10%, or what if we use a different grade of raw material? They can test these scenarios virtually to identify the most efficient workflows or potential problems before applying them in the real world.
So it's like having a crystal ball combined with a sandbox for your factory floor. You can test out changes without any real-world risk or disruption. That sounds incredibly powerful for continuous improvement initiatives.
It de-risks innovation and optimization. And that leads directly into the next area, smart production optimization and resource planning. Manufacturing plants frequently struggle with inefficiencies due to suboptimal resource allocation. Maybe the wrong materials are staged, or the workforce isn't designed optimally in rigid production planning that can't adapt quickly to changes. techicom's AI-powered solution aims to dynamically adjust production schedules, workforce allocation based on skill and availability, and material flow using that real-time data pulled from the integrated IoT sensors, the MES, and the ERP systems.
So it's constantly tweaking the plan.
Constantly optimizing, yes. The goal is to ensure maximum throughput, minimize bottlenecks as they start to form, and optimize the utilization of all resources, machines, materials, people. An industrial manufacturing firm, cited as an example, was facing frequent production slowdowns and missed deadlines. After deploying this AI system for dynamic scheduling and resource planning, they reportedly reduced machine idle time significantly, improved their on-time delivery rate by approximately 20%, and cut significant material wastage by dynamically adjusting workflows based on real-time conditions and demand signals.
Okay, optimizing production. What about the supply side? Procurement.
Good point. Moving upstream into the supply chain, they provide AI-driven predictive procurement and inventory optimization. Procurement inefficiencies and stock imbalances, things like costly overstocking of some items while having critical shortages of others, these lead to increased operational costs, tied up capital, and potential production delays. It's a constant balancing act.
Inventory management nightmares.
Totally. By leveraging historical purchase data, advanced demand forecasting models, which are also learning from real-time sales or production data, and real-time supply chain analytics, like supplier lead times, shipping delays, techicom aims to enable smarter purchasing decisions. This optimizes stock levels, aiming for just-in-time without the risk of running out. It reduces procurement costs through better timing and potentially volume discounts. It minimizes stockouts that halt production. And it significantly improves overall supply chain efficiency and resilience. An automotive manufacturer described as struggling with unpredictable raw material shortages and the resulting production delays apparently used this system. They were able to dynamically adjust their raw material stock levels based on real-time demand signals from their production lines and updated supplier performance data. This led to a much more stable, predictable, and cost-effective supply chain for them.
Connecting the dots from demand back to supply intelligently makes sense. And what about product quality itself?
Right, ensuring the final product meets standards. There's quality control for consistent production standards. Now, this goes beyond just the basic defect detection we talked about with VOS. techicom's data-driven quality control system uses real-time analytics from various sensors, vision, temperature, pressure, etc., and machine learning models. It aims to detect potential quality deviations early in the process, not just at the final inspection. It can help automate root cause analysis when a defect is detected, tracing it back to specific machine settings or material batches. And in some cases, it can dynamically adjust production parameters in real time to maintain peak quality and prevent defects from occurring in the first place.
Closing the loop on quality.
Exactly. The result is reduced defect rates, improved product consistency from batch to batch, and increased overall production efficiency because you're catching problems sooner or preventing them entirely. A manufacturing facility that partnered with Techicom reportedly saw their defect rates reduced by a significant margin. Product consistency improved across batches, leading to fewer customer complaints, and their overall production efficiency increased due to less scrap and rework, which also boosted their production speed.
Okay, one last area, the workforce itself. How does this unified platform help manage and support the people running these operations beyond just the safety monitoring from VueOS?
Good question, because technology needs to empower people. They extend their impact on workforce management and safety beyond just the vision capabilities in a couple of key ways integrated into the platform. First, there's the Plant Assistant for knowledge retrieval and training. We touched on the conversational AI Copilot. This is related but more focused on documentation. It revolutionizes workforce training and day-to-day operational efficiency by enabling instant, document-based knowledge retrieval. Employees can upload all their machine manuals, SOPs, safety procedures, troubleshooting guides, all plant documentation into the system. The AI assistant, powered by that BakParse capability, processes, analyzes, and can then deliver real-time contextual insights when asked.
So an operator having trouble can just ask the system.
Exactly. How do I reset the pressure on machine X? Or what's the safety procedure for clearing a jam on line Y? It significantly reduces reliance on finding a busy senior staff member for troubleshooting simple questions. It addresses knowledge gaps, especially with newer employees, and ensures quicker, more informed decision-making right on the spot. Imagine a new operator needing to quickly find a specific valve setting. They can just ask the AI instead of searching a manual or waiting for help. And related to this is the operator assistance and e-logging system, which we mentioned under Watchtower, but has workforce implications too. It digitizes those maintenance records and can provide guided troubleshooting procedures. This streamlines workflows, enhances decision-making by providing step-by-step guidance for common issues, and improves overall machine uptime by ensuring consistency in how problems are addressed. It replaces those manual logs with a central, searchable digital record that also helps track operator actions. A steel manufacturer, for instance, reportedly used this system to reduce maintenance downtime significantly. They also improved diagnostic accuracy because operators were guided through troubleshooting steps consistently. And they achieved 100% digital record keeping for maintenance activities, moving away from those inconsistent, often delayed or lost, paper processes that frequently led to errors or repeated problems.
It really does sound like a holistic approach, where the intelligence gathered in one area like machine health feeds into another, like maintenance scheduling or even procurement for spare parts. It creates this more integrated and potentially continuously learning, continuously adapting industrial ecosystem. This sounds incredibly robust, technically sophisticated, but for businesses considering this kind of transformation, implementation is always key. How does techicom ensure their solutions are actually accessible and trustworthy? Especially when you're dealing with such critical, often highly sensitive industrial data and control systems?
That's a crucial question, probably the most critical for adoption. How adaptable, how secure, how trustworthy is this technology in the real world? Techicom seems to address this directly with a highly flexible deployment strategy. They clearly understand that different clients have vastly different infrastructure preferences, data sensitivities, security postures, and regulatory requirements. One size definitely does not fit all here.
So, cloud, on-premise, what are the options?
They offer several deployment models, whether a client prefers. Cloud-native deployment, leveraging leading cloud platforms like AWS, Azure, or Google Cloud Platform, GCP. This offers maximum scalability, potentially reduced infrastructure overhead for the client, and often a faster time to value because the infrastructure is managed by the cloud provider. Or on-premise deployment. This is crucial for environments with highly sensitive data, or where stringent regulatory compliance mandates that data cannot leave the client's physical control. This allows clients to maintain full control over data sovereignty and security within their own private data centers, behind their own firewall.
Keeping everything in-house.
Right. Or, increasingly popular, a hybrid deployment. This aims to get the best of both worlds. You might keep critical data processing, real-time inference, and sensitive data storage on-premise for low-latency operations and maximum control. But you could leverage cloud resources for scalable AI model training, less sensitive data analysis, or maybe dashboarding and reporting accessible from anywhere. The key thing they emphasize is that their modular architecture is designed to ensure consistent performance and capabilities across all these environments. And importantly, to allow for seamless integration with existing legacy systems, avoiding that costly and disruptive rip and replace scenario we discussed earlier regarding cameras. It applies across the platform.
Okay, deployment flexibility is important, but in today's world, security and governance are absolutely non-negotiable, especially with industrial data, which, as you said, is often mission-critical, highly sensitive commercially, and frankly, a prime target for cyber threats. How do they handle that aspect? It's not just about functionality working, it's about building and maintaining trust in the system's integrity.
Absolutely. Trust is paramount. You can have the smartest AI in the world, but if people don't trust it or it's not secure, it's useless or even dangerous in an industrial setting. Techicom's architecture, according to their materials, is built on a foundation of robust security and stringent governance principles. It's designed to ensure both trust and control for industrial operations. This isn't just an add-on feature. It appears fundamental to their approach. They break it down into several key pillars.
Okay, what are those pillars?
First, foundational data security. This is addressed through multiple layers. End-to-end encryption is standard using strong algorithms like AES 256 for data when it's stored at rest, and transport layer security, TLS, for data when it's moving across networks in transit. This ensures sensitive information is protected at all points. They implement role-based access control, RBAC, a standard practice, to ensure users only access the specific data and functions they legitimately need for their job. Nothing more. They also state they operate within a zero-trust framework. This security model assumes that no user or device inside or outside the network can be trusted by default. Everything needs verification. And they use techniques like tokenized data handling where possible, further safeguarding information by replacing sensitive data elements with non-sensitive substitutes or tokens.
So securing the data itself, what about the AI models? They can have issues too.
Great point. The second pillar is AI model governance. This is crucial for maintaining the integrity, reliability, and fairness of the AI over time. It's not just about the initial deployment. This involves model auditability, often using explainable AI, XAI techniques and detailed logs. This means you should be able to understand, at least to some degree, why the AI made a particular decision or recommendation, making its logic more transparent, not just a black box.
Understanding the why, that's important for trust.
Hugely important. There's also continuous monitoring for things like model drift, where the AI's performance degrades over time as real-world data changes, and potential bias in the model's predictions or recommendations to ensure accuracy and fairness over time. Comprehensive version control for every AI model deployed is also key, so you know exactly which version made which prediction. And, critically, they mention having a kill switch capability, a way for human operators to manually override or disable the AI system in case of unexpected behavior or emergencies.
A safety net.
Exactly. The third pillar is compliance and standards. Industrial environments are heavily regulated. Techicom solutions are built, they say, to align with critical industrial standards. For instance, ISA 95, which is a standard defining how your plant floor systems, like MES, should interface with your top-level business systems, like ERP. This ensures seamless data flow and integration vertically through the organization. Then there's IEC 62443, which is becoming increasingly vital. It's a series of standards focusing specifically on cybersecurity for industrial automation and control systems, IACS, essential for protecting sensitive operations from cyber threats. And of course, they aim to meet general security management benchmarks like ISO 27001. Plus, they need to ensure compliance with data privacy regulations like GDPR, General Data Protection Regulation, in Europe, including controls for data residency, ensuring data stays within specific geographical boundaries if required. They also mention capabilities for digital signatures for legally valid audit trails, which is essential in regulated industries like pharmaceuticals or aerospace.
Okay, data security, model governance, compliance. What's the last piece?
The fourth pillar ties it all together. Trust and transparency. This goes beyond just technical security. It's about building user confidence in the AI itself. As mentioned under governance, Techicom emphasizes providing explainable decisions, revealing why the AI flagged an issue or made a specific recommendation. This is often supported by confidence scores. How certain is the AI about this prediction? And they strongly advocate for human-in-the-loop approval workflows, especially for critical decisions. This empowers operators to critically evaluate, sanity check, and ultimately approve or reject AI suggestions, fostering a collaborative approach. It leverages human expertise alongside artificial intelligence, rather than replacing it entirely. This complete commitment to these four pillars, data security, AI model governance, compliance, and trust and transparency, aims to build that enterprise-grade foundation needed for secure, auditable, and trustworthy industrial AI deployments. It's about providing peace of mind for their clients when adopting these powerful technologies.
So it's really not just about the technical prowess of the AI, but also the surrounding framework of security, auditability, and transparency that allows it to work with human operators effectively and safely. That sounds like a comprehensive approach to building that necessary trust. So bringing it all together, what does this all mean for the long game? Considering everything we've discussed, the reasoning AI layer, the specialized agents, View OS, Watchtower, Energy 4.0, the deployment and security aspects, why is techicom uniquely positioned for the future of industrial AI? What's their edge based on this detailed view?
That's a good synthesis question. Based on the materials, techicom seems to highlight their unique positioning through a combination of several crucial factors working together. Firstly, their deep expertise. They emphasize that their team combines decades of hands-on, practical industrial experience people who understand the grit and reality of manufacturing, oil and gas, etc., with cutting-edge AI development expertise. This blend aims to create solutions that truly understand the complex contexts and operational nuances of industry, not just generic data science applied loosely. That deep domain knowledge is key to ensuring their AI is relevant, practical, and effective.
So not just techies, but industrial techies.
Kind of, yeah. Secondly, they point to proven results. They cite successful pilots and deployments across diverse verticals, chemical, oil and gas, energy, discrete manufacturing like ceramics or automotive. And they claim tangible, measurable improvements from these, with some showing remarkable 30% plus efficiency gains in specific areas like maintenance or energy use. These aren't just theoretical benefits promised on a slide. They're aiming to show real, measurable impacts already delivered.
Real.
That's the goal. Thirdly, their scalable architecture. As we discussed, it's modular, it's cloud-ready, but also supports on-premise and hybrid. Crucially, it's designed to integrate with existing systems without necessarily demanding a complete rip and replace of a company's current infrastructure. This significantly lowers the barrier to entry and reduces risk for companies, especially those with substantial legacy investments they can't just abandon overnight. And finally, perhaps most importantly, their claimed user-centric application. They state they're laser-focused on solving hard, real-world engineering and operational problems, but doing so with simple, intuitive user experiences. The aim is that the entire team, from executive management needing dashboards down to frontline operators using a mobile app or conversational AI, will actually use, understand, and benefit from the solutions. It's not technology for technology's sake. It's technology designed for adoption and impact.
Okay, so that vision techicom is painting. It really isn't just about generating insights anymore. It's about anticipating issues, acting proactively, and ultimately creating this truly intelligent, perhaps even self-optimizing industrial environment. That feels like a profound leap from where many industries are today. What's the biggest cultural or maybe organizational challenge you've seen or heard about companies facing when they try to adopt this level of intelligence and potential autonomy? It sounds amazing on paper, maybe in a pilot, but changing how people work and trust new systems is often the hardest part, isn't it?
You've absolutely hit on a critical point there. Often, the biggest challenge isn't the technology itself, especially as it matures. It's frequently the cultural resistance to change within the organization. Operators, engineers, managers, people who are accustomed to decades of manual processes or working with older, familiar systems.
Yeah.
They sometimes view advanced AI with skepticism, maybe even fear.
Fear of what? Job losses.
That's often part of it. The fear of job displacement. Will this AI make my role obsolete?
Yeah.
But it's also often just a lack of trust in what feels like a black box system. How do I know I can rely on its recommendations? What if it's wrong?
Mm-hmm.
That's precisely why techicom's emphasis on explainable AI, XAI, and those human-in-the-loop approval workflows is so incredibly important from an adoption perspective.
Because it builds trust.
Exactly. It builds trust by showing the reasoning, the why, behind the AI's recommendation, and it keeps human expertise in the driver's seat for critical validation. It makes it a tool, a co-pilot, not an opaque overlord. Overcoming this cultural hurdle requires more than just installing software. It requires robust training, not just on how to use the tool, but on what it does and why it helps. It needs clear communication from leadership about how AI is intended to augment roles, making jobs potentially safer, less tedious, more strategic, rather than simply replacing people wholesale. And showcasing early tangible successes from pilot projects or initial rollouts is vital. When people see it working and making their lives easier or the plant run better, that builds confidence and fosters wider adoption organically. It's definitely a journey of collaboration and change management, not just a technology deployment project.
A human challenge as much as a technical one.
Absolutely. But the future that techicom envisions, enabled by their reasoning AI layer and these interconnected agents, it really pushes beyond just answering queries or providing historical insights. The goal is building truly autonomous, or at least semi-autonomous, industrial agents that will fundamentally transform operations over time. These future agents, they predict, will diagnose issues before they happen, making predictive maintenance truly predictive in a way that current systems often struggle with. Identifying potential failure modes weeks, not just days or hours, in advance, by catching those incredibly subtle precursor signals. This completely shifts the maintenance paradigm from reacting to emergencies to proactively preventing crises altogether.
Getting way ahead of the curve.
Way ahead. They will also recommend optimal operating conditions on a continuous dynamic basis, constantly analyzing real-time data and suggesting fine-tuning adjustments to optimize processes for energy efficiency, for consistent quality, for maximum throughput, whatever the current business priority is. This isn't a one-time optimization study. It's perpetual self-optimization baked into the system.
The plant learning to run itself better.
Essentially, yes. And critically, they will continuously learn from new plant data, creating self-improving systems that grow more valuable, more accurate, and potentially more autonomous with every interaction, every new piece of data they process, every outcome they observe. This is the ultimate vision for AI in industry. Systems that evolve and improve on their own, making operations demonstrably smarter every single day.
So it's really not just about insights anymore. It's about anticipating, acting, learning, creating this truly intelligent, self-optimizing industrial environment where the plant itself becomes a continuously improving entity. That's quite a future to contemplate.
Wow, what an incredible deep dive that was into techicom's industrial AI platform. It feels like we've covered a lot of ground. From that foundational reasoning AI layer, which really acts as the industrial brain, connecting everything, to those specialized vertical AI agents tackling specific high-value challenges like doc-parsed AI managing documents and compliance AI handling audits, to the powerful visual intelligence brought by ViewOS, turning standard cameras into smart sensors. And then the comprehensive Watchtower suite for asset health and Energy 4.0 for resource optimization. It's clear they're tackling incredibly complex industrial challenges with solutions that are intelligent, data-driven, but also designed to be secure, flexible, and built for user trust. We've seen through the examples and case studies how they aim to transform that raw data deluge into practical, actionable intelligence.
How they optimize everything, from the health of a single machine bearing right up to strategic procurement decisions, and how they help ensure safety and compliance across diverse sectors. It really does seem to be about more than just collecting data. It's about making operations fundamentally smarter, safer, and more efficient by understanding the present, predicting the future, and automating intelligent action. They're helping businesses move from that often costly reactive stance to one of proactive, continuous optimization. So, as we wrap up this deep dive, here's maybe a provocative thought for you, our listeners, to mull over. With this level of real-time insight, this kind of predictive power, and this potential for autonomous learning now becoming a tangible reality, what industrial process in your world, maybe one you've always thought was just stuck in the past or too complex to easily improve, could you transform? What stubborn inefficiencies could finally be eliminated? Or what new levels of safety, quality, or sustainability could potentially be achieved by leveraging such comprehensive interconnected AI? Think about the possibilities it might unlock for your own operations or industry. Thank you so much for joining us on this deep dive into techicom. We hope this exploration has given you a powerful shortcut to being well-informed on their approach and perhaps spark some genuinely new ideas for how AI can, and likely will, continue to reshape our entire industrial landscape, moving us all toward a smarter, more efficient, and hopefully more sustainable future. We'll catch you on the next deep dive.